let's move on to the next topic. If we have a vector valued function, when I have a function, I can differentiate, I can integrate it if I want to. I just need to know what it means. So let's look at this spatial vector valued function, cosine t and sine t. Okay. I said spatial because I know exactly what the curve looks like. It travels counterclockwise along the unit circle. Okay, so when t equals 0, you are here. When t equals half pi, you are here. So it moves this, and when t reaches pi, you get here, and you just keep going. And then you turn back, and then you do the loop one more time. All right. So now I can say I want to differentiate this vector valued function. And the way how we differentiate the vector valued function is we simply take the derivative of each component and put it together. Okay? So in this case, the r prime of t is equal to, all right, what is the derivative of cosine and what is the derivative of sine? Derivative of cosine is minus sine. Derivative of sine is cosine. Right? Okay. So here, what do I know? I know that, for example, at 0, r prime of 0, I'm seeing minus sine 0, cosine 0. Find out the values of 0 equals 0, cosine of 0 equals 1. So this is a 0, 1 vector. 0, 1 vector, according to our notation convention, 0, 1 is the vector from the origin to the point is 0, 1 here, right? But because a vector is simply a directed line segment, it doesn't really tell you where the starting point is. So we cannot differentiate this vector or this vector or this vector because they have the same length and the same direction. So when we work with tangent vectors, we may as well just draw the vector starting from where r of 0 is, or where r of t is. So I'm looking at r prime of t, and therefore I start from r0, that's here. And I have a vector pointing at 0, 1 direction of length 1, like that. So this vector is my r prime of 0. So one thing to notice is the vector you have is tangent to the plane curve. Okay, so let's do one more. If I look at r prime of, let's check this point. That's where t equals a half pi. So I have minus sine of a half pi, cosine of a half pi. So what is that? This is minus 1, because sine of a half pi equals 1, and cosine of a half pi equals 0. So what direction is this? It's the direction pointing along the x direction, but in the negative x direction. So it's like that. So if I start from r of a half pi and draw the vector, this is the vector I get r prime of pi over 2. Okay? So from these two examples, we are pretty confident and we understand that r prime of t gives a vector tangent to the curve. Which curve? The curve given by the vector value function. The curve at where? At r of t. Okay, so we see two examples. When t equals 0, r prime of 0 is a tangent at r of 0. R prime of a half pi is tangent at the point given by the vector, where is it? 0, 1. Okay, so this is point 0, 1. 0, 1 is what? 0, 1 is r of pi over 2. Okay. So from now on, we understand if we're given a vector value function, or if we're given a plane curve, or if we're given a space curve, or are given parametric equations, and we're looking for tangent vectors to the curve, we use the derivative of the vector valued function to find the tangent vectors. Okay.